In this lesson, we are going to discuss the locations of volcanoes. At the end of this video lesson, you should be able to enumerate and describe the locations of active volcanism. Volcanoes are areas on the Earth's crust in which lava comes out. Volcanic eruptions are usually accompanied by pyroclastic flows and tephras. What we know is that volcanoes are formed by the subduction of an oceanic plate beneath another plate. Typical volcanoes are found in these areas which we know as subduction zones. We know that volcanic arcs are formed in oceanic continental convergent plate boundaries, and volcanic island arcs are formed in oceanic convergent plate boundaries. A common example of a volcano formed along subduction zones is Mount Etna. It is an active stratovolcano on the east coast of Sicily, Italy, produced by the convergent plate margin between the Eurasian and African plates. Mount Etna is one of the world's most active volcanoes and is in an almost constant state of activity. Another notable location of active volcanism due to plate convergence is the Circum-Pacific Belt, or also known as the Pacific Ring of Fire. Since the Pacific Ocean is surrounded by convergent plate margins, it is associated with a nearly continuous series of oceanic trenches, volcanic arcs, and volcanic belts. Some notable volcanoes in the region are the Mount Merapi in Indonesia, Taal Volcano in the Philippines, Colima Volcano in Mexico, and Sabancaya in Peru. Most of the volcanoes which we know are found along convergent plate boundaries. However, a significant percentage of the world's volcanoes are also found along divergent plate boundaries, or the spreading centers. These areas are also locations of active volcanism because of the presence of the ridge. The crust which forms in the ridge is in the form of lava. Thus, volcanism occurs. The most common example of volcanism due to divergence is the Mid-Atlantic Ridge. We know that the Mid-Atlantic Ridge separates the North American plate from the Eurasian plate and the South American plate from the African plate. Although the Mid-Atlantic Ridge is mostly an underwater feature, portions of it have enough elevation to extend above some sea level, for example, in Iceland. This active volcanism due to divergence is evident in Iceland's geysers, which are vents in Earth's surface that periodically ejects a column of hot water and steam. Volcanism due to divergence also occurs along continental divergence, an example of which is Erta Ale in Ethiopia. Erta Ale is centered over the East African Rift System. This is a triple junction setting whose movements are resulting in the formation of a pull-apart basin or rift. After discussing active volcanism on plate margins, one may think that volcanism only occurs on these plate boundaries. However, there are also volcanoes not found on these plate margins. These are the hotspots. Hotspots are volcanic regions thought to be fed by underlying mantle that is anomalously hot compared with the surrounding mantle. The abnormally hot rock within the Earth's mantle which causes this is called the mantle plume. This volcano, symbolized by the triangles in the middle of the Pacific plate, is the Hawaiian hotspot. Zooming into this hotspot, we can see that the Hawaiian Emperor volcanic chain is made up of different volcanic islands arranged according to their age of formation. These seamount chains were not formed as a group, rather, these were created one by one. This cross-section diagram illustrates the hotspot area of the crust. The Hawaiian island is currently situated on top of its mantle plume. The Hawaiian island expands as the mantle plume releases magma, and the Pacific plate drags the island along its direction. The Pacific plate will keep on moving and dragging the island away from its source of magma until the volcanoes in the island become extinct. This explains why hotspot volcanoes become progressively older as they move away from the mantle plume. The volcanoes will then become seamounts as they become submerged underwater due to the movement of the Pacific plate. Mauna Loa, the world's largest subaerial volcano in both mass and volume, is currently active because it is still situated on top of the mantle plume. The slow drift of the Pacific plate will eventually carry Mauna Loa away from the hotspot within 500,000 to 1 million years from now, at which point it will become extinct. Overall, these are the locations of volcanoes in our planet. To end this lesson, let us review the following key points. Locations of active volcanism include oceanic and oceanic continental convergence, oceanic and continental divergence, and hotspots. The age of a volcanic hotspot island increases as it moves away from the hotspot. And lastly, hotspot volcanoes become extinct once it has moved away from its mantle plume. And that ends our discussion on locations of volcanoes.